Hi, everybody. Thanks for joining us again in another segment of a Lunch and Learn series. My name is Dana, and working with me today is Greg Bruntz. I think everybody out there probably knows us at this point. And today's topic that we're going to be covering is about two particular methods for how you could inspect a heat exchanger on an induced draft forced air gas furnace. We wanted to do this video for a couple of reasons. One of those reasons is that we've been asked multiple times if we could go through those methods or do a little bit better job of describing them to help guys out in the field understand what we're driving at when we're talking about a heat exchanger test. The other reason why we wanted to do the video was just simply to talk to guys about the fact that heat exchanger inspection is not just black and white. It's not something where there's just absolutely 100% definitive proof through testing methods, because the simple fact of the matter is that if you do the research, what you will discover is that there is no one manufacturer out there or other type of governmental body that will admit to a method for heat exchanger inspection that is absolutely 100% foolproof, guaranteed to provide you with the results that you were expecting each and every time you perform that test method in that manner. So that being said, what Greg and I are going to be doing here today, we're going to kind of walk you through some things about a heat exchanger. Obviously, we have one here that we'll be using for a demonstration model, if you will. We're also then going to go ahead and move right into a functional gas furnace. We're going to show you some of the steps along the way in terms of performing the test. I want to point out right off the bat that the two methods that we're going to focus on here, those do not apply to all manufacturers. We don't want to give you the impression that what we're showing you here today can be used across the board for any type of brand of furnace that you may be out there working on. You'll obviously want to, if you're wanting to apply those methods, you'll want to speak to those manufacturers specifically about whether or not they would allow those methods to qualify for purposes of warranty or whatever the case may be. But saying that, we'll go ahead and we'll jump right in on this. And the two things that we're going to be talking about today are the two methods, if you will. One will be the introduction of smoke into the tubes of the heat exchanger onto the primary side as it starts to make its way through the primary side and working towards the secondary. The second will just be the kind of a conversational description of the 2009 AHRI document for forced air induced draft heat exchanger inspection. If you just go out onto Google and type in AHRI inspection document, it'll bring the results up for you right off the bat. We'll also try to post a link or do it in an FAQ on our website as well so that you can get your hands on that document. But these two methods are the most commonly referred to when technicians out in the field are talking to guys in tech service. You may have other methods that you prefer. That's okay. We're not trying to say that these are absolutely, without a doubt, the best method, but we have to have a benchmark of some kind. We have to start somewhere so that we can provide guys out in the field some type of a roadmap, if you will, a guide to how they could effectively try to test a induced draft heat exchanger. So with that, we're going to go ahead and get started, and we're just going to jump right off. Greg and I will kind of work through what it is that we're doing when we are adding smoke into the primary side on a heat exchanger, kind of like this one here as an example. So Greg, what is it that we're expecting the mechanic to see when smoke is being introduced onto the primary side of this heat exchanger?
So I'm going to make mention of this more when we do the actual test in the furnace, but I want to kind of give you guys a preliminary first. In order to do this test, the only thing that's going to be running in the furnace is the main air blower. You're not going to have the inducer running. You're not going to have the burners on or anything like that. And it's also going to be my recommendation, even though it sounds like the more painstaking way to do it, when you do it on the furnace to actually remove the burner assembly, because having the burner assembly out of the way is going to make this test so much easier to perform. And obviously we're doing this not more as a maintenance check. This is we're going to this test when we really think we got a problem with the heat exchanger. So with that said, so what you're going to end up doing is we're going to use an incense stick to create smoke. And I mean, all you're going to do is you're going to get this thing lit, you're going to get it smoking really good. And then the reason why we tell you to use an incense stick and not a smoke bomb is because we need to control how much smoke we're putting in here. We don't want to use a smoke bomb that's entirely too much smoke. But with an incense stick, we get just enough smoke so we can see where it's going, we know what it's doing. And all we're going to do is get this thing lit up, and we're going to feed that smoke into each cell of that heat exchanger way up in there and just kind of hover it right in the middle. But like I said, as we're doing this, we got the furnace blower running to do that. So what are we after here? What are we after with this test? Are we after the smoke just literally getting sucked away from us? Are we after the smoke blowing back in our face? Well, both. If the smoke blows right back in your face, then we're obviously blowing air into that heat exchanger from the main air blower, and we don't want to do that. And secondly, if you got a breach in the heat exchanger, it could actually be because there's a breach in it and it's creating a vacuum on the breach. And it'll actually cause the smoke to get sucked away from you. So either way, that smoke up inside that heat exchanger should just linger in there because it's got nowhere to go, kind of. So, and with that said, what I'm going to do is I'm going to focus back on the heat exchanger a little bit. I'm going to turn this heat exchanger around and see what we're actually trying to get out of this test. Once we got the smoke in there, we got air blowing through the heat exchanger. So if you've got any kind of a breach or a hole or crack or anything in any of these primary tubes, now we're going to do the smoke to each tube individually on the front side of the heat exchanger. But if we got any kind of a breach, a crack, a hole, or anything, the main air blower is blowing air across this, and it's going to blow air into that breach and affect your smoke. Same as if you have a hole down here in the secondary. If you got a hole in the secondary tube anywhere in there, you should be able to pick that up on the smoke test, and it'll actually affect the smoke in the primary cell, even though it's way down here, because this is all interconnected through the back collector on the back of the heat exchanger. So even if you got a seal problem back here, you'll pick it up. So it really doesn't matter where the problem is, whether it's in the tube, it's in where the header assembly is, where your primary and secondary come together, or it's in the primary tubes themselves. This test, all we really want to know is there a problem? Is there a breach in a heat exchanger? I don't care if it's gasket failure, I don't care if it's tube failure, I don't care if it's primary, secondary, it doesn't matter. From Nortec Global HVAC, if you replace the heat exchanger, you're going to get the entire heat exchanger, secondary and primary. In an 80% furnace, obviously you don't have a secondary, so you don't have to worry about that. It's just going to be a primary heat exchanger test.
One of the things, too, that I want to point out is that when you are performing a smoke test on a heat exchanger, maybe much like this one here, let's say that maybe the smoke test was a little inconclusive for them. Maybe they happen to say, no, absolutely, through a process of elimination of a couple different methods, maybe I could see I had a little bit of flame impingement beginning to happen, or maybe I could see that I was starting to get a little bit of rollout or something like that. They may want to then see if they can absolutely positively quantify that there is a breach in the heat exchanger, and they'll ask if, is this the opportunity for me to go to something like, say, one of the service cameras that are becoming really popular. You want to go ahead and kind of elaborate a little bit more on the use of something like a snake camera and why it may or may not necessarily be the best tool in this application if trying to detect a breach in a heat exchanger, much like this one here.
Absolutely, Dana. So I got a camera here. We're going to talk about that a little bit. I'm going to turn this heat exchanger around and kind of give you the synopsis of what some guys will do with a snake camera. And I have to agree with you completely, Dana, that using a snake camera is not really the best tool to be looking for a breach in the heat exchanger. Although they have a lot of useful purposes, and I've used them out in the field myself and had great success with using them. One of the things I used them for all the time was to pull the blower back a little bit and look up in there to see if the secondary heat exchanger coil was dirty. So they do have their their uses, but for a heat exchanger, no, I don't necessarily think it's the best thing to do. Because the problem with the snake camera is the guy's going to get this thing all powered up, and he's looking at the camera, and he's going to shove this down in here, and he's going to start looking for a breach in the heat exchanger. But the problem with the camera is it's not, the picture's not clear enough that you're going to definitively be able to tell a crack in the heat exchanger, a hole in the heat exchanger, versus just maybe possibly a little rust spot. So not exactly what I would recommend using, and I do know there's other guys that would use them, and they'd actually go down here where the limit's at, and they'd shove the camera in there. Again, if you're looking at the outside of the heat exchanger, again, you may not get a clear enough shot to see that it's actually a breach in the heat exchanger. So that's why I kind of defer back to the smoke. I mean, if we got even a small hole in there, you should be able to pick it up with this smoke. I mean, obviously, if you got a bigger hole, you're going to get more disturbance to your smoke. If you got a smaller hole, you're going to get less disturbance to the smoke. So there is a little bit of an art to watching that smoke inside that heat exchanger cell and determining whether or not you actually have a breach.
The accumulation of service hours, if you will, on modern heat exchangers could make the use of a camera might kind of muddy the water more than it might help clarify a situation. But sometimes we will have guys that will attempt to say, well, I'm getting rollout, or they'll say that they're getting impingement, something like that. Rollout doesn't necessarily we shouldn't try to jump from A to Z in terms of we see rollout, that's got to mean we have a bad heat exchanger situation there, don't you think?
We have had it in the past where this is the top of your heat exchanger, and that's got a seal to the cabinet. And we've had where contractors would utilize an uncased coil, and they'd shoot a sheet metal screw through the cabinet of the furnace down through and hit this. This is a pretty thick metal, and it wouldn't pierce it. So it'd literally lift up the cabinet. Now you got a gap here. So when the main blower come on, it'd blow right through here, and your burners are right here, and you get flame disturbance. So, and some guys will look at it and think it's a heat exchanger problem when it really has nothing to do with the heat exchanger. So, yeah, and we also used the smoke in those instances to prove that that's where it was leaking. It wasn't actually the heat exchanger leaking.
Yeah, those are great points there. Rollout shouldn't automatically send you kind of into a mindset of, I must obviously be looking at a heat exchanger problem here. Even if you were to perform a smoke test as an example, and the results seem to kind of not be as definitive as maybe what you had hoped, we will always want you to err on the side of safety. So that's why, again, if you prefer multiple methods, we're not going to say that those don't qualify and that we won't want to listen to what you have to say or what types of evidence you're collecting, regardless of the method that you're using. Greg and I are just trying to point out to you the two that we most commonly use so that there's some type of a process that that you can refer to when it comes to the furnaces that we manufacture that have an induced draft heat exchanger. And so with that, let's go ahead now. We've kind of taken a look at this heat exchanger as an example. We've talked about or introduced the two methods that we're going to be using. Let's go ahead and move from just kind of the model demonstration, if you will, and let's move on to the actual furnace itself, and we'll get started walking everyone through the process of actually taking smoke introduction into an operable furnace so that they can see how that would actually work.
Operable or inoperable in this case, because obviously if the thing if it was functioning, we wouldn't be performing this test. But
there you go.
Anyway,
very true.
And in this case, actually, we do have an operable furnace that we're going to do it on. It was pretty hard to find one that definitely has a bad heat exchanger to do the test.
That's right.
Then again, I say it's operable, but we haven't tested it yet either, so we'll see. But anyway,
we may be in for a surprise.
But we could still, go over the process and how to do it.
So, Greg, if you were working with a guy who was out in the field and needed to perform a smoke test, what types of things would you walk him through in terms of the procedure to get that test done effectively?
First of all, obviously, we're going to start off by shutting the power off to the furnace. Then the next thing we're going to do is we're going to turn the gas off to the furnace. And then After we got the gas off, we can undo the union, get the gas line disconnected. And depending on your piping comes into the furnace, you may actually have to unpipe it, or you may be able to just roll it back out of the way. So in this particular situation, I'll be able to undo the union, and I'll be able to unscrew the manifold screws up here on the top of the furnace, and then I'm just going to take this whole assembly and just lay it back out of the way. Then the next thing I'm going to do is use my long nut driver, and I'm going to go in there and undo the 4 screws for the burner assembly. Obviously, I got to unplug the igniter and stuff like that, and the flame sensor, but I'm going to take that whole burner assembly, and that way it's out of my way, and I can lay that down on the floor and have that done. And then the next thing I'm going to do is set up the blower. The blower needs to be running at high speed, and most of the time that's going to be cooling speed. So I'm going to use a jumper assembly on the thermostat. I'm going to disconnect the YY2 wires off the control board so I don't run the air conditioner. And I'm just going to put a jumper from R to YY2 because this is a variable speed blower. So if I went to R to G, I'd only get 50% of the blower speed. So if I go to R to YY2, I'm going to get 100% of the blower speed, maximizing the airflow across that heat exchanger. And by closing about half the registers, I'm going to get a little more static pressure built up across that heat exchanger so that I get more air pressure pushing on that heat exchanger. If there is a breach, we got a good push of air to go into it. And then lastly, once I'm all set up for that, before I turn the power back on to get that blower to run at that speed, the other thing I want to do is disconnect the flue pipe. So I'm going to come down here just to the inline drain assembly, and I'm just going to undo the 5/16 screw down there, and then I can just reach back and pull that flue back out of the way. And then the other thing I'm going to do, just so I don't have any air disturbance at all, I'm going to put a rag in that pipe just so that any air blowing down that flue pipe can't possibly get in that heat exchanger, because I don't want any airflow inside the cells of that heat exchanger. I just want static air in there. And with static air in there and blower air blowing air around that heat exchanger, if I get smoke movement, then I know I got a breach.
So, Greg, it really sounds like, there is kind of an in-depth process here in terms of performing an effective and thorough smoke test on a heat exchanger. You certainly hit on a few steps beyond just calling for heat and shutting the gas off and waiting for the blower to turn on. It definitely sounds like just calling for G is not enough to do it as well, because that doesn't guarantee that we're going to have a high enough blower speed. So when guys are performing a smoke test out in the field, they're going to want to kind of walk themselves through that process to make sure that they're performing it as accurately as possible, and they're not setting themselves up for results that are less than definitive, and then they're just kind of right back where they started.
Well, and you should be able to tell just by the sound of the blower too. I mean, if you've got a bunch of registers closed and you got that blower running high speed, you ought to get some pretty good thump out of that blower, so you're getting some good air movement. And the process I just explained, it sounds more painstaking than it really is. So if we just get in there and get busy and do what we got to do, the whole test process shouldn't last more than about 15-20 minutes. And even putting it back together, I would say start to finish, maybe a half hour at the most. But obviously you got to have a longer nut driver, stuff like that, be able to get back in and get them screws to get the burner assembly out. But about a half hour total.
Sounds great. Okay, well, I'll let you keep going there.
All right, sounds good.
Okay, so Greg, I see you're going to use that incense stick. Is there any particular reason why you prefer using an incense stick over, say, something like a long, thin candle or something like that?
Well, yeah, Dana, absolutely. You want to use an incense stick versus a candle. The primary reason is the fact that the incense stick, all it's going to do, if anything, that you're going to drop in that heat exchanger a little bit, is a little bit of ash. And a little ash in there, it'll make its way down into the secondary heat exchanger, but it's not going to hurt anything. If you're using a candle, you're possibly dripping wax up inside that heat exchanger. You don't want to drip wax inside that heat exchanger. So
gotcha.
And also, the incense stick does a real good job of creating enough smoke that it's going to answer your questions for you. So here we go. I got an incense stick burning here. Just want to point out too, I got a string tied to a flashlight shoved up inside this heat exchanger. I don't recommend you do that. The only reason why I did it was for the purpose of this video, so you can see the smoke in the video. So, but I'm going to go ahead and show you what we'll be doing here. So what we're going to do is we're going to just take this incense stick, we're going to go up into that cell and get it in there kind of deep. And as you can see up in there, all you should be seeing is just the smoke kind of lingering up in there. It's got nowhere to go. You don't have the inducer running, so you're not sucking air through the heat exchanger, so the smoke shouldn't be moving. And unless you got some kind of impingement in that heat exchanger. Now, if you got an impingement, again, it could actually suck it away from you, or it could blow it right back at you. And as you can tell from what I'm doing with this one here, there is no problem in the cell of that heat exchanger. Now, we do want to repeat this process through each tube of the heat exchanger. But I mean, I let them linger up in there for quite a while. I mean, I don't know, 30 seconds, maybe a minute, and just kind of let that smoke build up in there. And then as long as you don't see any smoke movement, then go ahead and move on to the next cell. I do want to point out, even though this video is more for a breach in the heat exchanger, the other test you could do with this is if you think you got a restriction in the heat exchanger, which is really rare, but if you just got one burner rolling out and you do a smoke test and you don't see any impingement, well, maybe we got something blocking the flow through that heat exchanger. So then what you would do is at that point you'd hook the inducer back up, run just the inducer, giving it a call for heat. Obviously you got the burner assembly and everything off of here. There's no way it can light. And then we can just take the incense stick and put the smoke up in front of each cell and make sure each cell's drawing evenly, because it should be. So just thought I'd kind of point that out as another possible test you could be doing here. But so far with this heat exchanger, I'm happy. But I'm going to go ahead and, since I got it apart, I might as well, I'll go through and do all the tubes. But for the purpose of this video, I just wanted you guys to get an understanding of how to do it. So that's pretty much it. If we go through each cell and we don't see any disturbance, then I would move on to putting the thing back together, because obviously, in my opinion, the heat exchanger is definitely not the issue if you're not getting any impingement to that smoke.
I think definitely this is going to tie nicely into some points that we'll expand upon as far as other forms of testing heat exchangers. One of the things I definitely like about this test is how it is so visual, if you will. It's certainly something that a technician could basically demonstrate to the owner as an example and describe to the owner what is it that they're looking for when performing a test like this, and that way it's not too technical, if you will.
Correct. Well, I think that pretty much wraps up doing the smoke test on
I think so. Let's go ahead and I'll let you get that put back together, and we'll move on to the next one.
Sounds good.
Okay, so Greg, looks like you got everything put back together. Thanks a lot for performing that test. I think that really did a really nice job of very clearly illustrating what it is that we're actually trying to explain to guys out in the field when we are recommending a smoke test be performed on an induced draft heat exchanger if they were to suspect that they could possibly have a breach. Was there anything else about that test procedure that you wanted to point out to the audience?
Well, the only thing I would say is, keep in mind, if you were doing this on an 80% furnace, obviously the flue disconnection is going to be a little different. You're going to have a metal flue.
Right.
Again, you're going to want to disconnect the flue and shove a rag into it. And if you're doing a counterflow furnace, obviously, your burners are going to be in the bottom instead of the top. But the basic principle stays the same. So whether you're doing an 80% furnace, it's downflow, it's upflow. You're doing a 92% efficient furnace, it's upflow, it's downflow. The basic process doesn't change. So I think I would say that we covered it good enough that everybody should be able to, comfortably walk away from here and, after watching this, and be able to perform the same test that we did.
Is there anything in particular about, say, this type of heat exchanger, induced draft, if you will? Is there anything in particular about that type of heat exchanger that you think would allow the application of a smoke test to be okay versus a different type of heat exchanger where it wouldn't necessarily work as well?
No, I mean, in my opinion, as long as you've got a sealed heat exchanger and it's sealed from the airstream, I mean, I always kind of refer to it, to keep things simple, is, you kind of picture that heat exchanger like a witch's pot. the heat exchanger is the witch's pot, and you're blowing air around it. And if there's a crack in the pot, you're going to get air into the pot.
That's good. Yeah.
I mean, only we're doing it with a tube. So,
right.
You know, whether it's a drum style heat exchanger, or it's a tubular style heat exchanger, or it's a clamshell heat exchanger, the theory behind what we're doing there pretty much stays the same.
Okay, great, great. Well, thank you. So moving on to our second method that will most commonly be referenced by, especially by the guys in tech service when they're talking to mechanics out in the field. And that method is using the procedures that are laid out in the 2009 AHRI document. It's an 8-page document, and it's for inspection of the heat exchanger on an induced draft forced air gas furnace. And we perfectly understand that this is a document that is not without its detractors. There are people out there that think that that is a controversial document. There are people that think it's a perfectly legitimate document. And probably one of the biggest reasons why people would say that there's controversy with that document is that it's a 5-step method that's kind of outlined in that document. And really what they're driving at there is taking parts per million samples with a combustion analyzer in the flue pipe, in the return air, and the supply air stream. But there are people that point out that there are lots of things that can affect what a combustion analyzer might pick up in terms of parts per million in a flue pipe. And we perfectly understand that. We absolutely understand, and we are aware of the fact that it's not that procedure is absolutely bulletproof, because it is not. The simple fact still remains, though, is that when we are working with guys in the field, we have to be able to give them some kind of direction. We have to be able to provide them with procedures or tools or something that they can use on a regular basis, day in and day out, that if they were to call in, if they were to say, I believe I may have a problem with this particular gas furnace, this heat exchanger in here, here are the 2 methods that I used. First, I used my combustion analyzer, and here was my data regarding that. Here's exactly where I took my samples. I followed the AHRI guideline for a induced draft gas furnace heat inspection. I followed that 5-step method, and here's what my data said. I followed that up with a smoke test, and here's what happened during my smoke test. And so I believe between those 2 methods, those 2 test procedures, I believe I have a problem with the heat exchanger and that it most likely has a breach. I'd rather be safe than sorry. If a technician calls in and can say that, obviously the people on the other end are going to understand, you know, what he's talking about. It's not going to just be hocus pocus to someone that he's speaking with. Even moving on to as far as if it were going to generate a warranty claim, if you will. As far as the AHRI guideline, that 5-step method, obviously that involves a combustion analyzer. We are not going to go into how you use a combustion analyzer in this video. That's a different video for a different day. It's just simply that's the other benchmark, if you will. That's the other test that you will hear from us, Nortec Global HVAC, as one of the means of being able to prove or disprove whether or not you suspect you have a compromised heat exchanger. Again, the basis, the fundamental of the AHRI test is an analyzation starting in the flue pipe, and it generally, you're talking about operating the furnace for at least 5+ minutes. You're looking for flue pipe parts per million numbers that are exceeding 200 parts per million, and that's where it starts. Again, we'll try to provide a link for it or put that into an FAQ on our website. Otherwise, if you just go out onto Google, just drive open Google and type in there AHRI heat exchanger inspection. It'll bring that right up for you every single time, and you'll be able to click on that. It's already a PDF file, so you can just drive that right open and print that out if you wanted to keep a copy for yourself, or just have it so you could jot down some numbers, whatever the case may be. It's easy to get your hands on that document. But again, that's the other method, AHRI, our first method that Greg and I were demonstrating. Greg did a great job of walking you through that smoke test procedure. We're going to go ahead and get ready now. We're going to move into the question and answer portion for today's Lunch and Learn. Hope you guys enjoyed it. Again, we did this Lunch and Learn because we've been asked many times, it's been requested that we talk about heat exchanger inspection. What do we, if you will, what do we like to see, or what methods, what steps do we want to kind of have the technician performing out there in the field versus what we wouldn't recommend. Thanks for watching. We'll go ahead and we'll get started. And thanks for go ahead and participating in the series. Hope you guys like these Lunch and Learns, and we'll continue to do more as we go into the future.
Hi everyone, thanks for tuning in to another one of our Lunch and Learns. I got Dana in again. This just like last week. He's not on video, but we got a nice picture of him. But he's going to moderate questions for us again today. I hope you enjoyed this topic and doing the smoke test on that heat exchanger. Hope you got a lot out of it. So with that, let's go ahead and get rolling. And Dana, if you want to start rolling with some questions here, we'll get them answered. And if you got more questions, please type them in there and get them submitted to us, and we'll do our best to answer as many as we can. So whenever you're ready, Dana, let's roll.
All right, sounds great. Sounds great. All right, so Greg, right off the bat here, Mark is asking if I do the AHRI test and it passes that test, but then I follow up with a smoke test and it fails that test, what do I do then?
That's a great question. So what I would say is if it fails the smoke test in the way we just showed it in the video today, I'd rather you err on the side of caution. So I'd rather you replace the furnace if it qualifies for quality pledge, or replace the heat exchanger. I don't want to take any chances. So, and depending on how big the breach is in the heat exchanger, it may very well pass the AHRI test and not pass a smoke test. So as far as I'm concerned, err on the side of caution. If it won't pass that smoke test like we showed on this video today, then by all means, either replace the heat exchanger if that's what the warranty calls for, or a replacement furnace.
Yeah, I have to agree with you there, and kind of like it's pointed out in the video, the AHRI test, it's rather well documented. There is controversy surrounding that document. It's not foolproof, and I have to agree with you. If it fails that smoke test, better to be safe than sorry, always. Okay, so this next one, Greg, this one probably comes up at least 2 or 3 times in any given heating season when guys are starting, especially when they're doing installations on new furnaces. And the question is, why do I see open tubes sometimes in the secondary on a high efficiency furnace?
Okay, that is a great question, and Dana, I'm glad you read that one off to me, because it can be deceiving there. So what Dana's referring to is, in this question, is if you're looking at the secondary heat exchanger from the outside, so basically before the furnace is installed or whatever, and you're looking at the secondary heat exchanger, the outer rows of there, it looks like there's a tube in there just because of the way the fin pack is made with the secondary heat exchanger, but that doesn't necessarily mean there is a tube there. So it looks like it's damaged, or it can look like it's damaged, or it can look like we forgot to put a tube in there, when in all reality it wasn't supposed to have a tube. So and if sometimes you'll see that crimped a little bit and you think the tube's damaged, and it's not. So what I tell guys to do is just get like a matchbook, something real thin like that, and you can slide it in between those fins. If you got a tube in there, you'll hit that tube and you can't go any further. If it's just extra fin pack, you slide the matchbook in there and it won't actually go through there. It will go through there because there is no tube. So, and it's done like that because the same fin packs are done in multiple sizes, but we only put the tubes in there depending on the BTU of the furnace and whether or not it actually needs the tubes in the secondary part of the heat exchanger. So that's why it looks like, but if you look at it from the outside, it looks like there was a tube there. So, but yeah, you're going to have extra spacing in there where tubes may not be used, and especially in the smaller BTUs. So, hope that answers your question.
Okay. All right. Next one here, Greg. Mike wants to know, do you test and tear down returned units at the factory?
Okay, so when the heat exchangers come back loose, in other words, just a heat exchanger, they'll do a visual inspection on them. As far as the quality pledges and stuff like that, when they come back, yes, we do test the heat exchangers and make sure that it was actually a failed heat exchanger or what was wrong with the heat exchanger. So, yes, we do test them.
Okay. Okay. Next question here. What if neither test is conclusive? I had a furnace that absolutely would not make the pressure switches. Smoke test was fine.
Okay, I'm sorry, Dana, I missed the question. Could you repeat it for me, please?
Sure. So the question is, what if neither test is conclusive? And then they go on to say, I had a furnace that absolutely would not make the pressure switches. Smoke test was fine. So it sounds like they couldn't get the pressure switches to make, so they did a smoke test, but it looks like it passed the smoke test.
Okay. All right, I got you now. So that's a great question. If it passes the smoke test, and we're doing a smoke test because we can't close the pressure switches, and it clearly passes that smoke test, then we've got to start looking elsewhere, because if it passes the smoke test, it's not a heat exchanger failure. So we need to move on to what else could be causing us not to make a pressure switch. So a couple examples I'll give you right off the bat. If we're not getting enough vacuum to close the pressure switch, one of the first things I'll tell guys to do is disconnect the flue pipe. See if the pressure switch closed. If the pressure switch closes, then, well, you got a good possibility of something blocking the flue pipe. Another thing is, and I actually did this on my furnace at home, and I did it intentionally just so I could see what it would do and kind of give me something to help other guys with at times or whatever. So the furnace I put in my house is a 95% two-stage G7 TC. So what I didn't do, and there was not enough water in the P-trap in the blower compartment, and I knew that. I knew that before I even fired the furnace. But I fired up the furnace, and the pressure switches did close, and it was running. But if I would have kept it running, it would have caused problems, because what I could hear was it gurgling. It was gurgling back through the P-trap on the furnace, back up, and you could hear it right there by the collector box of the furnace, just gurgling like crazy. So I also knew by hearing that gurgling, it's not draining. So I only let it run for a really short time, about a minute and a half, something like that, and I shut it down. And when I shut it down, the water and the inducer shut off, the water just poured out of that collector. So I knew it wasn't draining. Fired the furnace back up the second time, no gurgling at all. Pressure switches made, no problems with the draining. So there was some water in the trap on my furnace, but again, not enough. And then you could actually have no water in there at all, and you'll suck free air right in there, and you'll never make that condensate switch if you're sucking air back through that drain line. So there's a couple examples of things that could do it. Another thing that is overlooked consistently and constantly, because it's just not something you go after right away. Pull the inducer off. There's a restrictor orifice behind the inducer in most of the BTUs. When you get in higher BTUs, it may not have one, but most of the furnaces have a restrictor orifice. So if you look at let's just say a 92%, a G7SC, the G7SC uses the same inducer for all BTUs. And the way we control the amount of air that flows through the heat exchanger, because your air is sucked in through the burner box all the way to the outlet of the heat exchanger. So we're sucking the air through the heat exchanger. It's a negative draft heat exchanger. But if we've got the wrong orifice behind that inducer, you may not suck enough air. So something else to be very mindful of. I'm not going to say that I would hope that that's not going to be an overwhelming issue with us, that we would be installing the wrong restrictor orifices, but I'd be lying to you if I told you it's never happened, because it has happened. So something else to be mindful of, just take the inducer off and check that restrictor orifice on the back. If you got a question about size, the part numbers are on the parts list, and you can always give us a call in our tech service department and we can verify whether or not you got the right one. So if it passes the smoke test and the inducer's coming up to speed and we're still not closing pressure switches, we got to start looking at what other things that could be keeping it from closing the pressure switch. So great question though.
Okay, so Greg, looks like we've got a few mics out there in the viewing audience today. Mike Houston at Mechanical Supply has asked, will a crack make a drastic difference with a cold versus a hot heat exchanger?
Okay, that's a great question too. Obviously, as you heat things up, if you got a crack, it's going to split more, but the split's not going to go away. So two things I would say to that. When we're doing that smoke test like that, we don't need a ton of disturbance to the smoke to be able to determine that the heat exchanger is an issue. So if we got a crack that does open up when it's heated and we're doing it cold, you should still get disruption to the smoke when you're doing the smoke test. So you should be able to still pick it up. Even a small breach in the secondary, you should still be able to pick it up because we're putting positive airflow into there. But another thing you could do is, fire it. If you can get the furnace to fire up and stay running, even if you don't have let's say you got a pressure switch that's not closing, okay? Well, we start it up, we bypass the pressure switch, we get it running, let it burn for a little while, let that heat exchanger get good and warm, and then shut it down, hurry up and get the burner assembly and everything out of there and do the smoke test when that heat exchanger is still going to be fairly warm. So, but another good question. Mike, you're absolutely right. As you heat that metal up, it's going to expand the crack. So if you can do it, after a warm cycle, yeah, you might get a little bit more disturbance. But even if you do it cold, if you got a hairline crack and you're closing registers, just like I said in the video, you're closing registers in the house to increase the static pressure. So we got more air pressure pushing on that heat exchanger. Even a small crack you should be able to pick up with a smoke test. So.
Okay, sounds good, Greg. Thank you. So this one here just actually isn't really a question per se. Ryan at RA Townsend just wanted to say, great video, guys. And he's having a problem finding the archived lunch and learns. Those are on the Nordyne Interactive Network. Ryan, if you want to send me an email after today's lunch and learn, dana.clark@nortech.com. We can get you fixed up there. That's no problem. Okay, so Greg, moving on here. Looks like we do still have a few more questions. Hopefully we can get these all in here. This next question, I know you've probably been asked this one 100 times from homeowners or for guys in training classes, whatever the case may be, but it has to do with carbon monoxide detectors. If you're going to have just one carbon monoxide detector in the house, where do you put it? Closest to the furnace or somewhere else in the house?
That's another good question. It's a controversial question because let's say you're in a house that has got a basement and your furnace is downstairs and there's no bedrooms downstairs, even if it's finished, but there's no bedrooms, but the sleeping quarters are upstairs and the main residence is upstairs. Carbon monoxide is heavier in there, so it's going to fall. So that's a legitimate question. Do I put it upstairs or do I put it downstairs? Well, depends. I would want it downstairs because that's where the carbon monoxide is going to fall, but I don't want it downstairs in the fact that they might not hear the alarm, depending on how loud it is. So, but keep this in mind. If you got carbon monoxide in the home and the furnace is running, the blower is circulating the air through the whole house. So in that situation, I would want the carbon monoxide detector upstairs where I know the person in the house sleeping could hear the alarm. But in that situation, my best advice is going to be that you have two, one upstairs and one down. So And if you're on a single level house, I would put it closest to the bedrooms so that you know they'll hear it in the bedrooms when they're sleeping. Again, you got a forced air system, so that air is being circulated through the whole house. So whether you got carbon monoxide in the kitchen, you're going to get it in the bedrooms too, because you got cold air return sucking that air through the entire house and dispersing it back out the register. So you just want to make sure you're placing those alarms where when they go off, even if a person's sound asleep, they're going to hear that alarm go off. And if you got a house large enough that you're afraid it won't be heard, then make sure you put it in, even a large ranch home, you may need two, one on one end of the house and one on the other end of the house. That's what I'm getting at. It's not so much it sense it with a forced air system, it's whether or not people are going to hear the alarms. So.
Yeah, great point. Okay, next one. Pretty straightforward here. Bill is asking, which test method do you like more, smoke or combustion analysis?
I definitely would defer to smoke because it's very visual. You can visually see that there's a problem, and when you're doing the AHRI test, there's so many other factors that can affect an AHRI test. Poor temperature rise, gas pressure's not set right. I mean, I can go on a list of things that can affect combustion analysis. So, the smoke test is pretty plain Jane, very, very, very visual to see and easy to say, yep, we definitely got a problem in here, or nope, we don't have a problem in here. So I would defer to smoke.
Okay. Next one here, Greg. So it's not really a question per se. Here's how it reads. I had a customer ask me what's dangerous about a bad heat exchanger. She's asking if the furnace makes carbon monoxide as part of the combustion process. It sounds like maybe this guy had a homeowner that thought, kind of like, you know what I mean? She didn't quite understand what was the dangerous situation if the heat exchanger failed.
Okay. That's a great question, and there's a lot of answers here. So let me start with carbon monoxide is a byproduct from burning a fossil fuel. The cleaner the burn, the less or minimal carbon monoxide you will have. So if that furnace is burning 100% correctly, you should have very minimal carbon monoxide. So what the other thing is, if you've got a breach or a compromised heat exchanger in any way, it's got to affect that burn process. So now how bad the breach is going to determine how bad we affect that burn process. So the other thing that I don't want to use a failed heat exchanger as a fear factor to the homeowner. Oh my God, you gotta do this because you can get carbon monoxide in your home. I don't think that's the right approach. I don't think we need to be using it as a fear factor. But we can explain what happens if we don't fix it. One, a lot of times you're doing a smoke test, you're doing it for a reason, because you're having pressure switch problems, you're having furnace problems where the furnace is not staying online, and you're doing a heat exchanger test to make sure that the heat exchanger is not the cause. So, but if you got a small breach in there, so the other thing I want to make sure we understand is majority of the furnaces, not all furnaces, but the majority of the furnaces out there are negative draft heat exchangers, and you're blowing positive air across the heat exchanger. So if you got a small breach in there, I said it in the video, they could actually create a vacuum and suck the smoke away from you doing the smoke test. More than likely, it's going to put positive pressure and blow the smoke at you. So the only way you're actually going to get any fume into the house is if it is actually creating a vacuum and sucking that out of that cell of that heat exchanger. So that burn process would have to be really compromised, and the furnace being able to stay on to actually be able to produce enough carbon monoxide out of the tubes of those heat exchangers to put enough carbon monoxide in the house that it's going to cause harm to the individuals there. So I would have to believe that heat exchanger compromise is really going to give you more where the furnace don't work because the heat exchanger's malfunctioned. It's got a breach in it or whatever, and it's affecting the burn process, or it's not even letting it burn at all. So again, I don't want to use it as a fear factor. Is if a heat exchanger's got a compromised heat exchanger, it's a seal. Everything as far as the burn process is supposed to stay inside that heat exchanger and then exhaust out the flue. And any chance of a leakage into the home, as simple as that. The heat exchanger's got to be replaced. The furnace has got to be replaced, whatever it may be. You know, whether we're doing a heat exchanger repair or a furnace replacement. Again, and I still want to stress to the fact that we should be taking this back more to it's a danger because it can affect the flame, it can affect the burn operation of the furnace. If the furnace stays on, you could have other issues with the furnace, but not as much as carbon monoxide poisoning. So the other phone call I get a lot too is the carbon monoxide detector is going off only when the furnace is running. Well, that doesn't mean it's coming from the furnace. It could be coming from anywhere. The furnace is circulating all the air in the whole house. So if somebody leaves their car running in the garage and the furnace is running, the carbon monoxide detector is going off because the car is running in the garage, not because the furnace is running. So again, the furnace is a forced air furnace. You're circulating the air through the entire house. So, but the whole purpose of this video is not to give a heating and air conditioning contractor the chance to use it as a fear factor that you got a defective heat exchanger, you need to buy a new furnace, or you need to replace the heat exchanger. I don't like that. I don't feel like selling a new furnace, replacing a part, whatever it may be, should be done by scaring the homeowner. And that's essentially what you're doing when you're saying, hey, this thing could put carbon monoxide out in your house, you could kill everybody. Let's not do that. That's my advice. I wouldn't do that. I would do it as, okay, it can affect the flame, it can affect the operation of the furnace. Chances are it could affect the burn of the furnace, and the thing's not going to work right. But on the same token, is if you have a compromised heat exchanger, I'm also going to tell you that I don't feel like it's safe to leave that furnace in operation until it's repaired. So, anyway, I hope it was a long-winded answer, but I hear way too many times where contractors are using the fear factor on homeowners about carbon monoxide, and I don't think that's the right thing to do. So, that's my opinion.
Yeah, I'd have to agree with you there, Greg. That's actually I think that's a great answer because that one we do get asked by homeowners, and they kind of instead of getting good information, they kind of feel like they're just getting kind of hit in the face with, this is a real danger. This thing's going to kill you if you leave it in here, and it really kind of makes people feel like they're getting. That they're just being preyed upon, if you will, when they're just looking for more information. So, okay, so looks like the questions are starting to slow down. Mike's just trying to be a wise guy here. He's just wanting to know what supply house has incense sticks, so you don't have to answer that one.
No, I like the question. I think it's great, so I will answer it, and probably none. But I've also got a smoke test at a smoke pencil, and for those of you that don't know, but where our corporate office here is and where I live in St. Charles County, mechanical supply is very close to us. So anyway, I think Mike's doing that intentionally, and that's okay. But I want to throw it back on him a little bit that I purchased one of his smoke pens, or he gave me one. I can't remember, but that thing stinks to high heaven. So I wasn't going to burn it in my house. So the incense sticks, I like those because they're real long and they don't stink so bad. And if you light a potpourri stick in somebody's house, they're more apt to be okay with it than some stinky cigarette or a smoke pencil or whatever. Anyway, but there's different ones on the market, and I know the supply houses are coming up with better stuff to do smoke test. and maybe we got one that ain't so stinky. But anyway, I don't really care if you guys use a punk from Fireworks. They work very well. Incense sticks work very well. You know, if you're in a home, somebody's house that they smoke cigarettes and you want to use a cigarette, use a cigarette. I just want to deter away from using the wax and using a candle because I don't want to drop wax down in the heat exchanger. But anything like that that produces good smoke, and you can control it. As you've seen in that video, I can control it in each cell, and that's part of the reason why I like the incense stick too. So anyway, but I like the comic factor sometimes. We ain't always got to be so serious. So.
Okay, so Greg, we got just enough time here. We'll do one last question here, and we're being asked if we were doing an inspection on a heat exchanger with a mirror, is there any place that we could recommend to kind of concentrate where we're looking at on the heat exchanger? You know, at down the length of the tube or at the return bends, where would you kind of concentrate if you were trying to do an inspection through using a mirror?
That's another good question. So, I mean, pretty much all of our heat exchangers now are the tubular type. So if I was looking for a breach, of, you know, physically with a flashlight and a mirror, I'd probably be looking at that first U-bend where your flame's going in, and that'd be the most heated part and most vulnerable spot to fail. But I'll caution, you know, if you can't see it with a mirror, doesn't mean it's a good heat exchanger. So that's why I like the smoke test. It looks like it's harder, but you do it enough times, you can have that burner assembly and stuff out of your way rather quickly, and you can do a smoke test pretty quickly, and there's no denying if that smoke's moving in that heat exchanger. So, and like I said in the video, it doesn't matter where it's breached. As long as it's breached, it's a compromised heat exchanger. So that's why I like the test so well. And that's why in the video I talked about using the camera, because if you're picking it up even with a flashlight and a mirror, a lot of times you're in a dark spot and you're getting a flashlight in there and you're getting a mirror. You know, sometimes it could just be a rust mark that really looks like a crack when it's not a crack. It's just a rust mark. So be careful what you do out there, guys.
Okay, well, looks like that's pretty much all that we've got here. I mean, guys are asking about some addresses and things like that for past lunch and learns, and what we'll do is I'll work together with our media people and our website people. We'll get something out there to kind of help walk you guys through exactly where to get the archived lunch and learns and all that kind of good stuff. But other than that, Greg, if you want to just kind of remind everybody about the next lunch and learn, and then take it away from there, and that'll wrap it up.
All right, sounds good, Dana. Thanks for moderating for me and giving me the questions. That makes things a lot easier for me, so I'm not trying to read questions and answer them. It kind of makes this whole thing flow a little bit better. I hope you all enjoyed the video. I really thought it was a really successful video because we get asked a lot about how to do a smoke test on the heat exchanger, and I think that turned out real well. I wanted to pass on one more thing, guys, and just don't forget about this one. So I showed you a smoke test doing the heat exchanger, but you can use a smoke pencil for a lot of other things. You can do looking for leakage around the front plate of the heat exchanger in the cabinet. You can use it to see if you're getting any air loss around the inducer, in between the inducer and the collector box. I may do some more. We may be able to do some more videos, you know, using smoke as a way to detect for other types of air leaks within a furnace. But I think you guys, a lot of guys, can see where I'm already going with that. So keep that in mind. You know, using a smoke stick of some sort to do a look for air leaks doesn't necessarily have to pertain just to a heat exchanger. So I hope you enjoyed the video. We have another Lunch and Learn coming up on November 8th. We're going to talk about our new split heat pumps, the split air conditioners, the new split systems, the design change is coming. So I don't want to spill the beans or anything. Some of you might already got a glimpse about it or whatever, but anyway, I think that's going to be something you guys are probably going to want to tune into and see what our next phase of split condenser is going to look like. So, and again, that's on November 8th. I appreciate everybody tuning in. And as Dana said, he's going to try to get this squared away so you guys can go back out and look at some of the videos that are already on the NIN network. And I appreciate you all tuning in. I hope you all have a great day and a great week coming up and a great weekend this weekend. So, and we'll see you again soon. Thanks for tuning in.